Okay, so you have to open a new, make sure that it's a project. You have to select the template, the steel template that you have downloaded on your computer. So we have to go to this steel template, open, okay, and we have a blank file with levels. We have two levels that maybe we will move or we will change those levels. It doesn't matter. But the good thing is that when we want to work with structure and beams, we have already loaded here a lot of beams, concrete beams, American standard beams, white flange. Okay, so we have different when we are working with trusses. We have some trusses here. So I named the truss after me. I think I deserve, after all this time, I deserve a truss with my name. And I'll show you how to do it if you want to create your own truss. Okay, and that's it. So let's start. We have to go to level 1. Well, in that steel template, I have already created the grid that we are going to work with. Okay, so we don't lose time working with or creating that grid. Well, I have a long span, a short span, and then we have these horizontal grids. Here we have numbers, here we have letters. Okay. The dimensions, it doesn't matter. Well, it matters because the long span has to be something above 40 feet. That is what we consider a long span. And the short one is around 16. Okay, that's fine. And this is 18. So these are the spans. Well, so we have a main bay here and a different one there. And then we have these horizontal elements. So there will be an order of trusses in this direction and then beams in the other direction. And well, I want to show you today the beauty of folding things. Okay, so folded structures. I have a lot of examples for, what can I say? Okay, so this is it. It's well, it's an outstanding. It's not a building; it's a stadium. And here you see that the roof of that stadium, it's made of something extremely thin, so it's not a huge structure or whatever, but it works because it's folded. You see that we have this thin structural element. If it were flat, it would fall, it would collapse. But as it is folded, it resists much better without any structural vertical structural element here. So the only structural element is there, and this is a huge overhang with, I mean, it might be, let's say, 100-foot overhang, something like that. And it works. Okay, so this kind of folded structure, you can minimize the material that you are using by maximizing the efficiency of the shape. So this is something that we should know. And what else can I show you? Okay, so this is another folded structure. You see that we have this. We don't have any structural element here. So by folding this shape or this shell, we can even have a light here. Okay, so it's I think it's interesting from the design point of view, and structurally it's quite good because without any vertical element here, we can have a long span. Okay, so and it works well because this is a very thin element, but it's folded, and this shape helps resist a lot of load. Okay, and we can have a long span with a minimum amount of material. And there are other yeah, so there are other examples of this kind of folded architecture in which you see how making the most of the shape, we can minimize the material, and we have these outstanding buildings in which you see how thin this is. Okay, and it's about the shape. So we have this folded shape, and we can resist a lot of load, and we can cover a long spans just by working with this kind of shapes. So this is what we are going to try to do. We are going to work with shapes, and we have to use the mass modeling feature of Revit. Okay, so we can't do this with walls, or I don't think so, or roofs. We have to use the mass modeling if we want to create this kind of shapes here. So this is what we are going to try to do today. Okay, so let's start. First, we need a structure, and these points, we have this grid. So on these points, we will have a structure. I told you that we are going to start with structural systems and the footings. Okay, so the foundations. So in these foundations, we had the footing, the rectangular footing, when we have rock, not very deep. And when we have a deep rock, then we need to use these piles. This is what we're going to use, this 4 pile with a cap. Okay. Uh, we have to calculate this, but I want to show you that depending on, this is the first thing that we have to understand when we are designing a building, what is the soil, what kind of soil we are working with. Do we have rock a few feet underneath, or do we have to go deep with 40, 50, 100-foot pile to find the solid rock? Okay, Nash, don't worry. I hope you can join us soon without any trouble. Okay, so first we are going to select those piles, and we can select this option at grids. We select all these grids, and then we have piles here. Amazing. And now we have those beams. We need to connect. Oh, by the way, I didn't save it. At grids, or is it saved? Let me see. No, it's not. Okay, isolate it. Add grids and finish. Okay, there you go. And what level are we working with? Okay, so yeah, so this is level 1, and we have to go below that level 1. Now, what do we need? We need the beam, the concrete beam connecting all these, let's say, yeah, this 12 by 24. It's fine. So now we have to connect all these. Okay, and now we can copy multiple. Okay. So now we have a solid foundation, and then we can start the structure. What kind of structure? Okay, so let's select the column. I didn't load here the concrete columns. Well, it doesn't matter because this is steel. Okay, yeah. So we're not going to use concrete structure. So we have steel, and for the columns, well, we have this. That's fine. And now we can select add grids, and we select all the grids. We click finish, and we should have columns. Oh, okay. So the level of the columns is not the right one. So I select all of them. Level 1, the top is level 2, and the offset is 0. I don't know why it keeps doing this. Okay. Okay, so we have the foundation level, and then we have the steel columns, and they are in the middle, or they are at the intersection of these grid lines, the vertical and the horizontal ones. You might ask, okay, is it relevant the shape of this? Because is it better this direction or this? What do you think? Okay, so this is a relevant question. We are not calculating structures here, but shape matters. Not only the shape, but the orientation of the shape matters. And depending of, because this is a column like this, we need to bear vertical loads, but we also need to bear horizontal loads, especially for wind. Okay, so if we have strong winds, we might have strong horizontal loads, and then that shape works well in with horizontal loads that are in this direction, in the vertical direction, and it doesn't work as well if the horizontal load is in the horizontal direction. Anyway, we don't know about the wind, but even the orientation of this matters. Okay, so we are not paying attention to this, but if we are calculating structures, not only the shape, not only the amount of material or the size of that column, but even the orientation matters. Anyway, if in this case, if the wind is blowing in this direction, in this vertical direction, that would be the right orientation. If the wind is blowing the other direction, or the strongest wind blows in that direction, then we should shift. Anyway. We have foundations, beams, connecting. Oh, I have one beam more. Yeah. So all these piles or all these gaps should be connected by concrete beams. And now it's something solid. It's much better. And let me see okay, so this is south, east, west, and north. Okay, let's work with the east elevation, east or west. Let's open the west elevation, the east, sorry, east elevation. So we have level 2, and do we need level 3? Well, I don't like this number, so let's make it 15. And let's make it 25. Okay. So now I want to create a roof. You tried the spline last time, so this is I wanted you to realize that you can do anything, and if you don't go crazy with the shape of your beams, you can adapt trusses to any shape. Today we're going to work, because these kind of shapes that I have shown you, they are not completely free. Okay, so they have a lot, they are basic, these are hyperbolas, or we can have circles, or okay, so if we don't go crazy, it's much better. And if we have symmetry, so that goes well. We can be free and we can do whatever we feel like. And the first time architects started doing whatever they felt like was with the Guggenheim Museum in Bilbao. Okay, so this is a very famous building. It's in Spain, in the northern Spain, in Bilbao. That was the filthiest city on earth about 30 years ago. But they built the Guggenheim Museum. Frank Gehry did it, and now, well, everybody wants to go to this city to see this building. And well, I think this building that I know of was the first building in using this kind of software, because this building was built in the 90s, in the early 90s. I remember that I was still a student when this building was under construction. And as you can see, we have these kind of shapes, and there is no rule behind this shape. So they needed a software to be able to do that. So they invented this. That was it. It wasn't made with, or the software they used, it wasn't Revit. It was something close to Rhino. It wasn't Rhino, but the same family of software. So they created this, and then they figured out how to build this, because no matter the shape that you can imagine, at the end we have straight elements, and we have trusses, and we have columns. Yeah, we can have this shape that is a curve, and we don't know what kind of shape this is. But when it comes to the structure, everything has to be uh, done by means of trusses, grids. So we need a geometry behind this shape. Okay, so you can do that, and I'll show you how to do it with Revit. But this is the first building that I know of that they use this kind of software, and the history of architecture changed, because it's not that you can't imagine this. Of course, you can imagine, but are you able to do it? Are you able to create a building out of a shape like this? Thanks to this software, and now we can. It's an outstanding building, by the way, so I like it. This is inside, but you see we have curtain walls, and these curtain walls are straight elements. Okay, so we find the shapes that are very weird, but when it comes to this, we have a geometry and we have straight lines here. So there is a way to divide these shapes into straight elements so that we can build it. And this is what we are going to learn today. Okay, so first, we are not going to go crazy. So we are not going to use splines. We're going to define things. Mm, yeah, so we're going to create curves, and we're going to do something out of the box. But we need to understand the geometry behind this. Okay. So if we want to do that, I'm going to use reference levels as well. Okay, so this is level 1, because I want to create overhangs. Okay, and what is the overhang? Okay, so we are going to define the overhang with these reference planes. So we are going to create 1 and 2, but we need to yeah. So I did it, but now we have to take a good measurement. What was the distance between? Okay, it was 18. Okay, so I want this to be half. Okay, so the distance between the grid line and the reference plane, I want this to be 9. No, the other way around. We have to select this, and I want this distance to be 9. There you go. And I want this to be 9 as well. Okay. So that is going to be the overhang. It's going to be the same overhang here than there. And here we have we need the same. So I can create another reference plane. And another one. And now the distance is always 9 and 9. Okay, so we have the reference names, the reference planes. And now the most difficult thing in Revit and in life is to give names to things. So what is the name of this? Okay, this is my own criteria, and because I have to clarify myself about what I am doing. So I would name this A, because this is the grid A minus 9. Okay, so we start AB. So this reference plane is A minus 9. And this one would be F plus 9. Maybe it's something stupid, but I clarify myself. So this is 1 minus 9. And this 3 plus 9. Okay, now we have 4 reference planes. And I can understand where we are, because now we're going to work in 3D, and we need to understand where we are and what plane we are working with. If we don't realize this, we are lost, and we are not able to do that. So we have to be very accurate, because if we are not, that's why with these kind of weird shapes, if we have a grid as a reference, if all the distances are the same or half the distance, or we need rules, and then we can be free designing the shape. But we need rigid rules at the beginning, because otherwise we're completely lost. Okay, so this is 1 minus 9. This is 3 plus 9. The other one is, so this distance is always 9. And yeah, this is 9. So the overhang is always 9. Okay, so we are going to draw the shapes in this reference plane in 3 plus 9, and in this 1 minus 9. So from the east elevation, I'm going to use this level 3 as a reference. And I'm going to start, okay, I'll show you what to do, because I'm going to work with architecture, model line. And last time we used the spline. Today we're going to use something different. So we're going to create a curve, but we need rules. Okay, so we are going to create this start and radius. And we're first we have to decide where we are. Okay, so we are in these 2 reference planes, 1 minus 9 or 3 plus 9. So we can start with this one, 1 minus 9. And this is the intersection between our level 3 and the reference plane. So this is the plane perpendicular to this one. So I'm going to create arches from this point to this point. So the span, it's going to be 18. Okay, it's the same distance as we have between grids, but we are here. And then the elevation, I don't know, I want to do something feasible. So you see that you can control the radius. Okay, so I will say that the radius is 12. There you go. And then without doing anything else, you can, well, this is 18 again. So click here. And now you see, if you move this, sometimes it stops. It stops here, and we have a this kind of arch, okay? But I don't want this. I want to go down and I want to find the tangent point. Here you go. Okay, you see that here you can read tangent. So again, if we are working with curves, we need these points because if we have this, it doesn't look well because here we have like an edge. So we don't want edges. So we want tangents. So when you are hovering here the mouse, here it stops at the tangent point. So create the tangent. And now we go back. Now we go rightwards, 18 again, click. Here you have the tangent. Another one, 18. Another tangent. 18. Tangent. And finally, intersection with this reference plane here. Here. And tangent again. Be careful with this because this point is confusing. So we have this shape, and as you can see, there are no edges here, and this is important. If there are edges, things are not working well. So we have a smooth transition because we have selected tangent curves, so that works well. So this is my first shape. So this is the, okay, so this is the shape here. We have an overhang, 9 feet. And now we need a different shape. We're not copying this shape, we are doing something different, but in this, at this point, at this edge. It's always good if you select this, you know where you are. You know that we are in reference plane 1 minus 9. Okay, so you're not completely lost. Maybe you don't remember where did you, where you created this shape, but if you click on it, we know where we are. We're at reference planes 1 minus 9. So now from the east elevation, we want to model another line. The reference plane now it's the 3 plus 9. It's opposite this one, and we are going to create a mirror line. So I'll do it again instead of so I can start from this point, and I will end here. But now we are not going. Sorry, because I have to select the arc with radius. So first point, second point, and you remember that the radius was 12. So 12. So now here, tangent, here, tangent. And tangent. Okay, if we look at the 3D, we see the shape is here. If we click here, they should be plane 3 plus 9. And if we look at it, we see that they are not the same shape. Okay, so they are different. And this is what we are going to connect now. We are going to try to do this. I think I showed you that building. No, it's la Sagrada Familia. Escuelas. Yeah, I wanted this one. Okay, so we're going to create a structure like this, but if you remember, this is the shape that we're going to do. Okay, so you see that this is a concave and this is convex, and this is convex and this is concave. Okay, so we're going to do something like that. Why? I like it. Okay, so this is what we are going to do, but we can do this with Revit, but we're going to figure out what the structure of this element should be. And If you look at this, we always have these elements. We always have beams, okay? Straight beams, they are not curved, so they are straight. So that's why we need to be very accurate. And although it might seem that it's something weird, there is a fixed geometry behind this shape. So that's the starting point. We need two curves or two lines. They are the same, but they are not, yeah, they are shifted, okay? So it goes up and down, and that goes down and up. Okay, so now we are going to make a roof out of these two lines. And this is difficult. And I don't know if you are doing this. I think I'm not going too fast. If I'm going too fast because you want to do it as I'm speaking, let me know and I will slow down. But I want to give you time if you are trying to do this on your own right now, because this is going to be difficult, and it's going to be difficult because Revit has a complicated process to do this. In other software, I'm doing this would be a piece of cake, but in Revit is not that simple. Okay, so we're going to use this feature, massing and site, this tab, massing and site here. Okay, massing and site. And we're going to use the in-place mass. So here with this, we can do a lot of things. This is mass, whatever, name. Imagine that we are working with a rectangle. Okay, if we start at level 0, at level 1, sorry, I can create a rectangle in level 1, and then I can create form, a solid form, and then I can change that shape and finish mass. Okay, this is a mass with a shape that it's not straight. We don't have, if we want to make it even we can edit and we can select this and we can make it even. Okay, so now we have a shape or a volume without any parallel lines. If we are using the massing and site, we can always use roof, wall, and even the curtain system. Okay, so if you select roof, you select the roof, create roof, and that shape becomes a roof. And here you can select the basic layers of roof, and you can edit the type of roof and create a new all layers that we need. Same thing with the wall. Okay, so you can select this. Massing and site, wall. It's not visible in 3D. But here we do have a wall. Okay, I don't know why we don't see that in the 3D view. Maybe for the visibility graphics. Should be. Anyway, and we can create curtain systems. Okay, we can select this, we can create a system, and we have a curtain wall. Okay, so this is useful if we are designing architecture that doesn't have flat slabs or horizontal slabs and vertical walls. Using massing, it's good, and we can create the mass. We have freedom to create the mass, and then if we want to turn these elements into curtain walls or roofs or walls, We can do it, by the way. And then we can always change. But now we are changing the roof. We are not changing the mass. This is the mass. So if we want to change the mass, we have to do this. Okay, so now we have an element, which is a roof, and it doesn't have to do with the mass that was the origin of this roof. Okay, the same thing with the curtain wall. So here we have glass and we have mullions and transoms. So we have structural elements and we do have glass here. Okay. So that's a way to work with masses. Okay, we select in place mass, and here we can draw something. We can start with a rectangle, but we can also draw lines. We can create a solid form. No, sorry. We can finish mass. Then we can select this. We can always edit this in place. We select all these. We create a solid form. And now we have an element again. And we can twist this and we can do whatever we feel like. Okay. But the most important thing is to understand where we are. Because by default, if we select massing, in place mass, by default, we are at, we start drawing and we are at level 1 by default. If we don't want to start drawing at level 1, then we have here all the grids and the reference plane. Imagine that you want to work in reference plane A minus 9. So this is the plane in which we are drawing. Okay, so this line is not on the horizontal plane, it's here. Okay, but we have already created those lines. Okay, so we're going to work with massing, in place mass, and we have already created this. What is the goal? We are going to connect this line to this line and see what happens. But first, okay, so we have to select this pick line tool. Okay, by selecting this tool, we pick the lines that we have already created. But as you can see, yeah, you can see that by default, we are on level 1 and we are not on level 1. Where are we? I don't remember. And as I don't remember, I have to go back. I have to click on this one. Okay, so this is 1 minus 9. Okay, and this is 3 plus 9. So I'm going to start with this one. So in this one, we are in the reference plane 1 minus 9. Go to massing and site, in place mass. Okay. We have to select this, pick lines. And now we have to let Revit know where the lines that we are selecting are. You can tell me, okay, we are selecting these. These lines are on this plane. Well, they are not. So we have to let Revit know that we're in this plane 1 minus 9. And now we can select all these 1, 2, 3, 4, 5, and 6. Okay, we have selected these lines in this reference plane 1 minus 9. Now we have to do the same with the other one, but the other lines are in a different reference plane. It's a 3 plus 9. Okay, so we have to select plane 3 plus 9, and we select 1, 2, 3, 4, 5, and 6. Is it enough? No, it's not enough. We have to select this modify. And now we have to select both, and finally we will connect them. Okay, so now we select this. I keep Control pressed, so I can, you see the plus sign here. So I am selecting this one as well. And now we can create a solid form. Yep. and finish mass. Okay. So now once we have done this, there are lots of things we can do. If we look at the top view, it seems like, yeah, they're like rectangles, but the curves are different here and in there. I think if we use shaded or
Fernando, I have a question.
yes.
Do you mind just really quickly repeating how that process worked for the in-place mass? I did the steps and nothing showed up.
Okay, I don't mind at all.
Thank you.
Because I know that this is, it's not easy, and sometimes it's frustrating because it should be easier, but it's not. But are you here? So have you created these lines or these two curves?
Yeah, those lines are all set.
Okay, so now massing and site. In place mass. You have to select here, pick lines, because we are not creating that from scratch. So we are picking the lines that we have already created, pick lines. And now these lines are on the, I will cancel again. And I'll show you that this line is on this reference plane, 1 minus 9, okay? So massing inside, in place mass, okay, pick lines. And now we have to select here 1 minus 9, because this is the plane we want to work with, okay? So we have to select all these, 1, 2, 3, 4, 5, 6. Be careful, because if you select something that it's not the line we want to work with, you have to start again. Okay, if you by any chance you select now this structural beam, be careful with that. I don't know, probably it won't work. Let me see. Okay, so this is the first. Now we have to pick here again, pick lines again. We have to change the reference plane. It's not 1 minus 9, it's 3 plus 9. And we have to select all these. Are we done? No. We have to click modify. And
Fernando,
by clicking, yep.
When I select the lines, it's not turning black, like they're staying green. So I don't know why they're not like all selecting.
Yeah.
Can you share your screen?
I'm working in the lab, so I don't have Revit on my computer right now.
Okay, who's having the same issue with this?
Erin, she's also in the lab with me.
Okay, so you have both the
I am too.
Oh, Dylan, and can you share your screen to see what's wrong with it? Dylan?
I'm not zooming on the device I won't be able to share screen.
Okay. Let me try to find out why, and then I'll get back to you. But let me, if you click here, and then here, create form and solid form. Okay. When this happens, because this is too complicated, maybe for the first time in your life that you're using this feature, this Revit feature. So let's keep it simple, and let's try something easier. So imagine that we have the east elevation. So let's try to do this with two simple straight lines, okay? So we are working with architecture, model line, but we need to know what plane we are working with. So we are in plane 1 minus 9. So let's create that straight line. And then in this reference plane, let's work with 3 plus 9. And let's do something like this. Okay, that seems easy. Now, let's try to do it again. This is 1 minus 9, and this is 3 plus 9. Okay, so let's start massing, placing mass, pick. The plane is 1 minus 9, and then you select this one. Pick again, change the reference plane, 3 plus 9. Then you select that one, modify. But this is what you are, you mean that these lines are not black, or because look at this, it can be either black or green. So I don't know if it's an issue. Now we select this one and we select that one. We create form. And there you go. But I mean, the line can be either black, green, or whatever, it doesn't matter. So Erin and Olivia, have you tried this? Is it working?
I'm trying it now. It didn't work for me.
Or
Do you have to hold control down when you're selecting all of the lines in the same reference plane?
yeah, okay, I'll do it again. Yeah, maybe. Okay, so we have the two lines here, okay? Massing and side, in place mass. Okay, pick. Since there is only one, you can select this one. Oh, but it's see what happens when you don't change this. So when we are in level 1 and then we create form, this is what we are creating because we are working on level 1. Okay, so that's why we have to change the level. Okay, so let's do it again. Pick lines, change this, reference plane 1 minus 9, this one. I don't, so this is my left hand, so I'm not doing anything with this left hand. So just pick here, change the reference plane, 3 plus 9, select this one. Okay, now you click modify, and now you have to use control. Okay, so you have to select this one, and then you have to press control and select that one. And now create form, solid form, and finish.
That worked for me that time.
Okay. So yes, I'm going to do this again because where are we? Delete. If we delete now, if you select all these and we filter, we have lines and we have mass. Okay, so if we don't select the mass, we still have the line here. We still have the green line there, you see? And we do have the mass, so we have two things. So now I'm going to delete the mass and I keep the lines. So I'll do it again. Now, the thing is that we have to press control as we are selecting all the lines. So let's do it. Massing and side, in place, pick, select the plane, and now you have to press control. So the first one, second, but you need to press control to do this. Okay, now we don't press control, pick again, change the plane, and now we do have to use control again. 2, 3, 4, 5, 6. Okay, modify, select this one, press control again, and create form. There you go.
It worked for me that time.
Okay, great.
Thank you.
No, but this is tricky with Revit. I don't know why it should be easier. I don't know. I have to talk to them or complain or whatever. Because if you select the line, it should realize what kind of where you are or what you want to do. If you select these lines and these lines, they should. I mean, the software should be intelligent enough to understand that what you want to do is to connect these two shapes, but it doesn't happen. Okay. So this is it. We have this nice thing. And now we can use the roof tool. We can, instead of in place, we can create a roof out of this, roof by face. Okay, so this is exactly what we're going to do. We have a weird shape for that mass. We click here. Okay, that's interesting. As you can see, we can't select everything. So we have to, because this roof is not made of just a piece. This is because we have selected a line that it's not a spline, it's something different. So we have to select all of them. We have to create roof, and now we have a thickness. Okay, so when we do this, and here, if we filter, we have a line, we have a mass, and we have a roof. So we have 3 elements. Sometimes this is confusing. We have the mass that we have already created first. Then we have the line, and this is the green line that we created from the beginning. And we do have a roof. If you look at these consistent colors, it looks, well, it's beautiful, but we have this hatch here because we are looking at the roof and the mass. So I recommend you, once you have created the roof, I recommend you select everything, filter, select just the mass, and hide by category, by elements. And now we only have the roof. Okay, so the mass is there, but we are working only with the roof. And I think it's easier to understand. Okay. So we do have this nice roof. And now we have to create the trusses. And should be easy. Let's, but we're going to create 2 kinds of trusses. We're going to create a truss in the perimeter of the room, and then other trusses to make the structural elements, the theme structural elements. So let me do it. We have to go back to level 1. What is this? Basic wall. Let it. And now we want the trusses here in the columns. So we have to go to structure, sorry, truss. And well, here in this template, you have 2 kinds of trusses. You have this Fernando flat truss and this Howe flat truss. Why do we have 2? I'll explain it later. But so far, we want this. We want the one that has a vertical and diagonal webs. Okay, so we want this one. We don't want just the other one with the top chord. We want a truss like this. And let's start with this element and then that one. So if we go to the 3D, we have this truss here. I don't know why you have to change this, because as you can see, the top chord and the bottom chord, they are, if you edit type, the top chord, we have to set it to this MW shape. the top and the bottom. Okay, that's much better. It was a concrete beam, so it doesn't make any sense. Trusses are made of steel. We don't have concrete. Okay, now it's easy because we don't have to modify the profile. So last Tuesday, I showed you how to work with the editing profile. Now we have just to attach top and bottom because we do have a roof. When we have a roof, we can attach the top to that roof. And come on. Ah. Okay. And well, I started this on level 1. Let's edit work plane and let's start this truss on level 2. Coño, pasa aquí. Start level, I don't know what this offset is, 0. Pero qué cojones. Okay, let's do it again. So I'm going to, I'm going to open level 2. And I'm going to place the truss on level 2. And to edit type. Edit the top and the bottom chord. So here, select this W shape. The bottom chord is a W shape again. Apply. Okay. Yep, that's nice. And now if we select this, attach to top. Okay, that's better. Well, actually, I liked the other option, so I'm going to change my mind. I'm going to delete this line of columns. I'm going to work with level 1 because now I want to I need a truss in this on these 3 on the grid 3. So we can use the truss again, this flat truss. And we start at this intersection. And here we go to the 3D. Select the truss, attach top. I like it. Okay. So we're almost there. Okay, now we need beams in the other direction. Okay, so as you know, we always have trusses. Those are the main structural elements. And then connecting trusses, we need beams. So let's do this because our goal is to, yeah, we want beams like this in this direction. Okay, so these are the curves. Here we have walls. We don't have a wall now, we have trusses. And then we need beams in the other direction. It's too small. Yeah, we need those beams now. Okay, how can we do that? It's quite easy because we go to level 2. We have trusses in grid lines 1 and 3, and now we want beams in grid lines A, B, C, D, E, F. So let's do the first one. And for the first one, that's why I wanted this reference plane, because we want this beam to go beyond this envelope, and it will be an overhang here. So we have to select the truss, but we have to select the one which has only the top chord. I can show you how to do it. You know, okay, so here, if we insert here, this truss, the original one, you know that we can edit the family. And if we do this, now instead of loading it into the project and overwrite the existing version, you have to save that file. Save as a family. And this is Fernando's flat truss. So you can name it Fernando 2 truss. Save. Okay, and now you can load it into the project so that you don't remove the existing one. Okay, so that's I told you that we were going to work with families. So this is the first thing. You can edit your family. It's a very basic because we have deleted everything. We have only left the top chord, but now you have created your own family. And we do have this one because this is the original one. You can delete it. But now when we are working with level 1, no, with level 2, sorry, and we insert this truss, so we have Fernando flat truss and Fernando 2. Okay, great. I have 2 trusses named after me. So now select this one from this reference plane to the second reference plane. We go to the 3D. It's here. And now we have to select this one and we have to attach to top again. We select the roof and we attach it and we delete the bottom chord, and we have it's not a truss, it's just a beam. And this is where we have it. Okay, now it would be great if we can have these beams matching these vertical elements. Okay, so since we have created, this is symmetric, we can do that easily because we have 1, 2, 3, and 4 vertical elements. 1, 2, 3, and 4. How can we do that? Well, we can, if we copy, so if we're on level 2, we have this truss here. We select this one. And we know that there should be 5 elements because we have 4 vertical elements. 1, 2, 3, 4, and this is the 5th. So we can always use this array. We can move to last. And how many elements do we have? We have 5. So the first one, this one is the first, and then we need 4 more. So in total, we have 5. And we have to move to the last. So if we click here and there, we are having 5 elements. And do I have to click somewhere? I don't think so. Okay, so where are we? There you go. Okay, the only thing is that I have copied, but I haven't copied, so I have to attach these to the, oh, first, you see that I have copied as an array, and it belongs to a group. So first I have to ungroup all of them. And now I have to select each element and attach to top. I have to do the same with all of them. I think if we had a wireframe, it would be easier. I can select this, attach to top, select this, attach to top, and this, attach to top. Come on, it's great. So it's matching the vertical elements.
Fernando, how did you do that array again? Could you show that?
Yep, I'll do it again. No, I want to check that. Yeah, so the horizontal elements are matching the vertical ones. So it's I'm very proud of myself. Okay, I'll do it again. So you have this one, the first one. We
I
can
do.
keep it. Okay. So you have to select that one, and on level 2, we have already selected that beam, and we know that between these two axes, between A and B, between these two grid lines, there should be 5 elements. Why? Because if we look at the east elevation, between 2 grids, we have 1, 2, 3, 4, 5 vertical elements. Okay, so we have to copy this 5 times. But if we use this array, we know that if we copy this, the distance between different elements would be the same, and this is what we want. By default, you have to number 2, but it has to be 5. And by default, I think you have move to second. You have to select move to last. Why? Because we're going to select, this is the first point, and this is the last point. And between these 2 points, between these 2 grids, we need 5 elements. So we move from this to this. And it's not shown here, but if we go to the 3D view, even to the top view, we can see that we have 5 elements, 1, 2, 3, 4, 5. Okay, the thing is that all these elements belongs to the same group, because when we are working with arrays, we have the 5 elements belong to the same group. So we have to ungroup all these. And now one by one, we can select and attach. There you go. Now, if we want to complete this, what can we do? Select level. So now if we select this one, we are not selecting the array. We are selecting the just the last one. Okay, we have selected the last one. And now, how many of them do we have? We have 1, 2, 3, 4, 5, 6, 7. A ver. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. It's too much. So I'd better do this one by one. So I select the array, move to last 5 elements, and then from this point to that point. Okay, so it's there. And now I'm going to do the same. I select this one. No, it's not there. Well, I have to ungroup everything. I think if I select the 5 of, no, I have to select. Yeah, if I select all of them, I can ungroup. And then with all of them selected, no, the attachment, it has to be one by one. Okay. Okay. So now you can continue with the rest of the base, but we are done. And now it's quite good because we can take good pictures of this if we work with a perspective. It's yeah, I like it. And but I think it's better if we work with the orthographic view. So if we work with the section box, and then we have a section here. Now we can go to the perspective. Yes, and we see. Or let's see if this view is better. Joder, coño pasa. Let me try with the camera. View camera. I think it's nice. Well, we need a floor here, but it looks like something professional, and it looks like professional because if you look at this intersection, all these lines are matching on the same point, and the vertical uh, web of the truss is aligned with these vertical elements with the columns. So everything is fine here. So everything is working well. Let me work with the camera. Well, it's too dark. Yeah, it's promising. So we can have good renders out of this.